All right. So now we're going to talk about blockchains. Blockchains were all the rage in 2017 when Bitcoin got up to about $20,000, and now it's back up to $9,000 or $10,000. So a considerable number of companies continue to think blockchains are going to do us a lot of good someday, although so far it's all just sort of prototypes. Anyway, there's a nice blockchain you can just play with right here in a browser without installing anything, so you can see how it works. So here's a blockchain with a series of blocks of data. And you can put data in here like Sam has 10 coins, and then data like Sam gives Caitlin 5 coins. And on you go. And over here, Joe has 1 coin. So you have information about financial transactions that you fill in. And these blocks are red because they haven't been mined. But you can mine them here, and when you mine them, you change this nonce value randomly until you happen to hit a value that creates a hash, which has a certain number of zeros at the start. There's nothing, that's just a problem, which is unpredictable and requires a lot of calculation. And once it's mined, this is now considered unchangeable. And you take the hash value from this block and you put it in the next block. And when you mine this one, it changes that nonce to make this hash start with a certain number of zeros. And then you mine this one, and that's called a blockchain, which is a special case of a data structure called a Merkle tree. And the point of this is, if you verify the latest block that it has the expected hash and that the hash matches the hash of the data, you know that the entire chain has been unaltered. If somebody tries to change something back here, like Sam wants to say he has 11 coins, as soon as you do that, all the blocks are broken. So that's what makes it a blockchain, and it's designed for financial transactions or anything else where you would have a lot of people writing to the database, and nobody ever wants to be able to change what happened in the past. So anybody can add new data into the new block, but once it's mined, it can never be changed. So you can have business contracts and financial records, event logs and other things where you need some kind of legal proof that you signed this agreement, you promised to do this, there it is. And that's why people try to apply this to ownership of property and genuineness of merchandise and so on. Although so far, I'm not aware of any much in the way of real world applications, but an enormous number of people believe that Bitcoin and blockchain is going to revolutionize the world. Anyway, so here's a simple demo. So you can just get the idea of how it works, and you can play with that and set up and find some flags. And then you can go to the second one. If you go to the Coinbase tab, there's a more realistic simulation of the way Bitcoin really works. For one thing, in Bitcoin, you have multiple peers making copies of the database, and they all have the same data. And the other thing is, the way Bitcoin works is when you mine a block, you earn money. So here, this looks like these have already been mined, but the point is, let me just change something here. Like, I'll change that name there. Now this block, so when you mine them, a bunch of people are trying to mine it, and whoever first mines it wins an award. So here they win an award of $100 by mining it. And in that block, it says who got the $100. And then you can mine this one. Here's transactions to make. So here's money from one person to another. See, now Anders has some money because he did the mining. So now Anders can give money to other people, and they can give money to other people, and on you go. And that's how the blockchain works. And it has the same structure that the hash of this block is included in the next block. So it has the same property that if the last block matches the hash, then you know the whole chain is intact. And that's what Bitcoin is. Anyway, so we got a challenge here where you set that up, modify some of the values, and find a flag to show that you've learned how to do the simple blockchain demo. And if you want to do a more realistic blockchain, you can do Hyperledger, Iroha. IBM is one of the many companies that is very bullish on Bitcoin, and they have put a lot of effort into developing a whole suite of blockchain products, not Bitcoin, but blockchain. And so the simplest one is Iroha, which is designed for mobile applications. So that's the one I use just to make it easy to set up. And you can put the Iroha blockchain on your Linux machine. You end up running it in a Docker container, but you just execute a few commands and you will have a blockchain running. And you can make this blockchain you can use from the command line. You run this iroha bin bash command, and now you can do things. Make a new transaction, make a new query, so you can create a coin, and you can then allocate some money and send money into the account. So you can send it from one person. Here, 1,000 cool coins go to one of the accounts, and then you can move some of it to another account, and you can go back and verify that it's all there, and you'll see how the blockchain works. So it gives you some practice setting up and running a real commercial blockchain that is designed for use in business. And here you can see the security problems of this. Remix is here. Remix simulates the Ethereum blockchain in JavaScript in your browser, which is very nice. So you have accounts that are created here, and you don't have to install anything, and you don't use any real money or use a real blockchain, but you can practice using Ethereum. And the point of Ethereum is, unlike Bitcoin, you can run a program on the blockchain. They call that a smart contract, and you can run smart contracts here. And so what you do is you can go get the POWH coin source code. This is a real blockchain, a real smart contract a few years ago that people on 4chan made, and people invested $1 million into it, and it got hacked and it all got stolen. And you can repeat that hack. So this is just 300 or so lines of this code, which is a language called Solidity that looks very much like JavaScript. It's used to write Ethereum contracts, and you paste it in that simulated Ethereum, and you can then run it, and now you can do things like invest money and fund the thing by investing money, and you can transfer money from one to another. You have a group of accounts here, and each account starts with 100 Ether, which is the currency in the Ethereum blockchain, and they can invest it in the fund, and they can move it from one account to another in the fund. And you can see the flaw here, and the flaw is that there's a combination of transfer functions, and one of them has a bug in it. So you can arrange a transaction that subtracts 1 Ether from an empty account. And it has an integer underflow problem. So when you subtract 1 from 0, it rolls over and turns into a huge positive value, 2 to the 256 minus 1. So you can take an empty account and it can suddenly have all the money there is. And that's what was used to steal all the money. Somebody stole $1 million out of this. So you can reproduce the whole thing here. And it lets you see that even though blockchains are in principle very secure, the only thing secure about them is that you can't change the contents of the blocks after they've been mined. But if you run some kind of contract on it, your contract can have bugs, and that can create insecurities. So some people say blockchains are unhackable and they're very secure, and it's not that simple. Part of it is very secure because of the hashing and cryptography, but there are other parts of it where you can still make the same kind of mistakes that cause all the other security problems.